This is to take you through the concepts for example 10. The first thing to remember is that Avogadro's law says equal volumes of gas contain the same number of particles. And that means if you've got, say, a certain number of particles, let's say a mole of gas A, and then you've got another mole of gas B, well, equal volumes of gas contain the same number of particles. That's the same way as saying if you've got gas with the same number of particles, they'll have the same volume. So if you've got 1 mole of gas A, that'll have a volume A. If you've got 1 mole of gas B, that'll be volume B. But because they've got the same number of particles, i.e. a mole of particles, they'll both have the same volume. That means that 1 mole of any gas at a certain temperature and pressure has a fixed volume. Okay, we call that the molar volume. And also, if we've got 1 mole of gas A in this container, and then we've got 2 moles of gas A in this other container, both at the same temperature and pressure, it means that this gas volume here must be twice the volume of the 1 mole of gas, because each mole of gas occupies that certain volume. This occupies 1 mole of volume, this one will be 2 molar volumes. And it follows from that the volume of a gas you've got is the number of moles of that gas you've got times by the molar volume of a gas. And as I said before, that's called the molar volume. And we can summarize that into an equation that the volume of a gas you've got is how many moles of gas you've got times by the molar volume. Or if you want to add it to our collection of mole equations, the number of moles of gas you've got is the volume of the gas you've got divided by the molar volume. And it's that equation we're going to use to solve example 10. And example 10, it says that hydrogen gas occupies 90 litres at 25 degrees 100 kilopascals. How many moles of hydrogen gas are there? So our data is the volume of hydrogen gas is equal to 90 litres, and we've been told it's 25 degrees C and 100 kilopascals. It doesn't hurt to write that down because there's going to be plenty of questions I'm asking you where I'll change it to 0 or 25, and on your data sheet it's got the different molar volumes. So we can look at our data sheet now, and you can see the molar volume at 25 degrees and 100 kilopascals is 24.79 litres. That means a mole of any gas at 25 degrees and 100 kilopascals is 24.79 litres. We're trying to find how many moles of hydrogen gas we've got, and we've got an equation for that. We've got number of moles is the volume divided by the molar volume. In this case it'll be 90 litres divided by 24.79. We take out our trusty calculators. 90 divided by 24.79 tells me that I've got 3.63 moles of hydrogen. So if I've got 90 litres of hydrogen, that's the same as having 3.63 moles of hydrogen. Example 10b, it tells us or asks us what volume will 1.033 by 10 to the minus 5 moles of chlorine gas occupy at 0 degrees and 100 kilopascals. So we're trying to find the volume, but we're told it's 0 degrees Celsius and 100 kPa. So the molar volume is going to be a bit different here. Looking at our data sheets, the molar volume at 0 degrees Celsius and 100 kilopascals is, trying to find my data sheet here, it's 22.71 litres. I've been told the number of moles is 1.033 times 10 to the minus 5. And all I've got to do now is use my equation. Number of moles is volume divided by the molar volume, or rearranging, volume equals number of moles times the molar volume. It's going to be 1.033 times 10 to the minus 5 times 22.71. Take out a little trusty calculator again. 1.033 times 10 to the minus 5 times 22.71 tells me that that is going to occupy 2.35 times 10 to the minus 4 litres. So if I've got 1.033 by 10 to the minus 5 moles of any gas at 0 degrees, it'll occupy 2.35 times 10 to the minus 4 litres. You might want to start example 11 as well. Example 11's got a trick though. It's got mass involved as well. So for example 11, you've got to use the relationship the number of moles equals mass over molar mass, and then use that relationship to find the number of moles before you use this equation. Oops, that's not the right equation. Oh dear. So you've got to combine both equations in order to solve those problems in example 11. In example 11a and example 11b, we will do them in class. If you want to try them in advance, that's what you can do.